Hey guys, Matt Young here with Flowco, and welcome back to another e-learning series. Today, our guest host is Michel Romer, Principal Engineer with ExxonMobil. Thanks for making the trip out to sit down and talk to us today.
Thanks, Matt. Happy to be here.
Yep, I'm excited for it. I think we've got a lot of topics to talk about, a lot of exciting things when it comes to how to operate gas lift, and more so how to operate gas lift when we're getting limited, incorrect, or just flat out bad information.
It never happens.
Oh, I know it. So hopefully we can show some points on, what we can work around, maybe how to validate some of that testing. Really, with your experience and your position, get some insight from you on, how do you combat that on a day-to-day basis, and from your experience, what you've seen, ways to kind of work around it is a big thing, because just like you mentioned, that limited information is quite frequent, and you start to make a lot of assumptions and a lot of guessing, and that doesn't really help when you're trying to improve production, limit injection rate, allocate that injection gas correctly,
Create a design that works
without putting 15 gas lift mandrels in. Right.
Yeah. 100-foot brackets or so.
Because technically, I guess you could do a gas lift system like that if you have limited information. That just put a lot of holes in your tubing at that point.
That's right. Yeah.
The only argument I guess you could say behind that is you save on production tubing costs.
That's right. It must be cheaper. There's less metal or holes in, right?
So really want to pick your brain about that. Thanks for sharing a lot of presentation content. We won't go through all the presentations, but we'll at least be able to kind of pick out some of the specific topics, because I know you've done quite a bit with that validation process, different tools to use, and really excited to kind of get your insight on that. And, because what we run into is infrequent well tests, and then when we do actually get a well test, the GORs are completely different from one well test to the other. Water cut changes by 50 or 60% when you're like, this should not really change.
Dynamic wells, Matt. Come on.
That's right. Well, and when I get a question a lot too is, when we see water cut increase, why is there gas lift changing our water cut? And I'm like, well, in an unconventional well, we shouldn't see that too much, but really want to kind of talk through that. And, outside of that, really share some of the tools that we can use if we disagree with the information that's coming in, how to kind of validate that. I know you shared a lot of really good information with me to kind of walk through some of those things. So excited to share that with the audience and let them take a look at it. Really, before we get started, one other thing too, if anybody has any questions, you can post that in the chat function for both of us. If it's a really good question, we'll kind of stop the discussion and answer it then. If not, we'll save it for the end and then kind of wrap up the discussion with those chats. Okay, so perfect. Sound good?
Sounds good.
Ready to get started?
Why not?
You got coffee, you're ready to go, right? So, one of the things that we see, Michel, when it comes to collecting data for gas lift systems, either collecting data to prepare design, like you mentioned, or after the the design's been completed and the equipment's installed, how to confirm our point of injection, how deep we're lifting, are we lifting where we should lift, and are we injecting the right amount of gas to get the drawdown we need, right? And so when I look at those kind of digital readouts, one of the first things I think about is, how are we collecting that data? And then two, how are we validating that data, either to complete a design or post design and install? And wanted to get your thoughts on that. Like, what do you experience with that, and kind of what your preferred methods are?
One of the key words that you said there, Matt, is digital. And even today, we still have fields and wells that don't have digital data coming in.
Okay.
I was just in one last week, actually.
Really?
And we had some of our gas lift technicians out last year to a field way up in middle of nowhere, Canada, called Norman Wells Asset. And all their gauges are still analog, to where you need to send people out to go and get any data.
And just record a data point
Exactly.
every day that they go out on location.
Casing pressure, tubing pressure, you name it. And
Oh,
one of the
man,
things
old school with
yes.
a tally book and everything.
And it may even be like a Barton type recorder. Yes.
If you gave me a Barton type recorder at this point, I don't know if I'd be able to read it. I think I'd struggle trying to read one.
That can be a challenge, yes. But even with that, there are things that you can run into from analog data that you can see happen in digital. So one of the things with analog is if you are having to send somebody out to record this manually,
Mhm.
sometimes you'll see day after day the exact same number for your casing injection or maybe your tubing production pressure.
I've seen that before.
And
835 every
single day. Maybe it'll make 836 or 833. You never know. But that's one thing to look out for. Sometimes that helps you know that it's time for another test.
Mhm.
And you can see that with digital devices too, where there's something wrong. It may not be with the gauge itself.
Mhm.
It could just be with the transmission from the gauge back into your SCADA system where it gets hung on a number.
Mhm.
And so it helps to look backwards a bit to make sure that things are within maybe an expected range of what that number should be. And with digital data, you should not just have a flat line number.
That makes sense. Yeah. So you're talking about going back and trending that historical data point, be it injection pressure, tubing pressure, maybe even injection gas rate, things like that. I know we've run into that with comms issues on downhole gauges where maybe we lose comms and then it just kind of gets stuck at one point. And you're right, is that every single day it's 2,200 PSI, and it's been 2,200 PSI for months. And you're like, I would love to have an unconventional well that can maintain a pressure like that, but
even a conventional well, that's a stretch.
Right. No, and that's a good point. And like, so one thing that I like to look at from that is trends are our friends, right?
Right.
That, I like to scale, and my personal thing is I like to go back maybe 90 to 180 days and look for that, like you mentioned, that kind of flat line. Or another thing that we can share is, actually we can share it now while we're talking about this, is the severe drops in pressure, right? And that's another one that, here, I'll jump ahead a few slides, kind of look at that. We'll come back and revisit some of these other ones. Let's see. I know I had it in here somewhere. But yeah, you're right. Is like
shares.
What's that?
You can just share it for them.
You guys should see it on this one, right? Sharing it through here. Yeah. So okay. So sorry guys, we've changed systems. So we're trying a different system here, and really like. Oh, here we go. This is what I was looking for. We're trying out a new system, and this is the first time we've gone like real live with it. We've beta tested it in house, but bear with us on a few things. But barring the downhole gauge information, when you talk about trending, like if we look at our blue line here, which is our injection pressure, like we shouldn't see either a flat line you mentioned, or one of the things I also like to consider is we shouldn't see like severe cliffs, like anytime something's dropping off. And, for me, that tells me either we've stopped injecting or we've developed a hole or a leaking valve, and, really looking at it from that aspect.
I was thinking of something else when we were talking about believing in pressures or not. And early in the days of AI machine learning, we did this project where we had a field and we gave all the data for gas injection rates, pressures, production rates, and kind of fed it into a black box system that would try to link the outputs of production to the inputs of all the data. And in the result, you get kind of the things, maybe the top 5 list of what it is that affects your production on the platform, so you can better optimize it.
Oh, I see.
And so, of course, number 1 was like it would say, okay, well, production rate, and then having gas lift gas to start, things you would expect. Another one was the casing pressure. But about number 3 or 4 on the list was the certain pressure gauge. And according to this black box AI machine learning system, this pressure gauge was in control of a lot of production on the platform. So I'm like, that's weird. Let me look at that. So look at the gauge, and the gauge was reading negative 27 psi.
Oh, wow.
Which is not physically possible.
Yeah.
You can't get to a negative pressure that low.
It'd be very difficult to.
So not all is what it seems sometimes. So if you are seeing a weird value or things, you just have a suspicion about it, one of the tools that's real cheap, easy to get, easy to send out is just a high accuracy digital gauge that's portable, battery powered. It's where you can go find a needle valve close by to where you're injecting out or producing from and screw that in and see if it matches up to what your primary one coming into SCADA shows.
Oh, I see. So you can use that as like an auditing tool.
That's
to
right.
Confirm that. And now that you mentioned that, I guess at this point I have enough years in the industry that early on digital transducers were kind of rare. And so you're right, you have a lot of analog gauges. And one of the things that we would see is at 7 o'clock every day, they're checking this well. And then the next well is at 7:15 and the next well is at 8 o'clock and so forth. Well, you lost that other 23 hours and 45 minutes.
Blocking out
exactly of what happened. And so we became really big fans of a digital data logger to where we could go and screw into a needle valve and then just essentially track, say, 24 hours and have the lease operator just take it off the next day that person was out there. And then you could actually see, like, is that pressure correct? Like you mentioned, is it wildly swinging to where he just times it to where he catches it on the low end, but it jumps up to 1,000 PSI 5 minutes after he leaves.
As soon as he walks away.
Exactly. Yeah. So that's a really good point. And, for me, when you start to build that troubleshooting toolbox, that's something that maybe you could just like throw in with your fluid level gun to have a couple running around out in the field.
Exactly.
And that, it's battery powered. It just logs data for however long at whatever frequency you want it to. And then you can just move it from well side to well side.
It's great too if you already know you have a well that's sluggy or has issues like that, to where if you're already putting it into test and maybe you're getting the volumes from the well, but not necessarily the pressures, then you can have that additional tool in the kit. And we see that a lot when our gas lift experts go out to troubleshoot wells, is it comes down to trying to validate and QC the data that you're getting. It's always nice to have a second device to where you can try to verify what you're seeing is really what's happening.
That makes a lot of sense. And, when you look at troubleshooting the system or just simply trying to confirm where you're lifting from, I can see having that secondary point to just confirm, like, are we operating off multiple valves based off of the oscillating pressure? If we're looking at injection pressure, is the well slugging on the production side? And, kind of give us, some paths to start to go down on, do we need to adjust injection gas? Is there something else causing these issues? Or is everything, is that oscillation within range of one operating valve and everything's fine? Maybe we could stabilize it with some more injection gas.
And when it comes to the gauges of the types, I mean, I'm just happy to have digital data coming in and logged, and preferably all in the same place when it comes to SCADA, so that you can stack trends on top of each other to compare and see what's going on there.
Oh, I see. Yeah. And that's a good point is, we experience that a lot of times when we're sitting in office with oil and gas operators, is they might have 3 or 4 screens pulled up and injection pressures on this one, production rate is on this separate system, and downhole gauge pressures on this third one. And I can see that I know it's very difficult because you have to jump from screen to screen. And I don't know if you guys experience at Exxon, but a lot of times when you leave one screen and the next to reload the previous screen, you have that awkward 30 seconds of nothingness, of just silence in the office while you're waiting for it to load. And then you're over here hoping that it actually loads.
Usually that happens when you're trying to show someone something live.
Oh, of course, yeah. We run into the same thing when we're trying to show an example of something and it's worked up until the time we're ready to show it, and then that's the time we lose communication, or it just sits there and gets stuck on the reload.
So there are some other data points that are easy to get, but that are often overlooked, but they're quite helpful. So we talked about casing and tubing pressure.
Okay, the obvious ones, right?
Obvious ones, but then the flow line pressure. So, because then if there is still a choke in the system, which for gas lift, we prefer not to have a choke, but usually there's still one there. You can look at if there is a pressure drop across the choke. Maybe the well's being held back on accident. We saw a well like that last week where there was a 100-pound pressure drop across the choke to the gathering system that shouldn't have been there.
Wow.
Which we fixed by the time that we left. But that's a good one to have. And then also, and we're bad at this, but they're almost free, so it doesn't make sense why we don't have it, is temperature. Just flowing temperature on the tubing. It's so useful when it comes to gas lift for nodal analysis matching, just to know if your well is flowing or not. I mean, you can walk up to a well and put your hand on the flow line and know if you're producing or not. Unless you're in a steam application, don't do that.
Yeah, no kidding. Or Eagle for new well.
And
or
it's
something like
the
that.
same with the gas lift side. Having temperatures on the gas lift side, especially the pressure and temperature upstream and downstream of your gas lift injection choke.
Okay.
Or a control valve.
Okay, so I'm familiar with the production side temperature, and I understand that one. And tell you the truth, I'm really glad to hear somebody else mention that
Or complain
about it. Because I'll tell you the truth, I feel like a crazy person when I talk to people about production temperature probes, and I either get this like glass stare back or people highly discount it. So back to the temperature on the injection side. What are we looking for in that? Because to tell you the truth, this is the first time I've really heard that kind of data measurement being important.
Well, I think of it mostly when it comes to injecting with wet gas lift gas,
which is probably 90% of U.S. lower 48 basins.
So it's more about where's the gas going?
Okay.
Is it making it to the well? And so you can see that with pressures or with temperatures too, if you're getting a hydrate buildup somewhere, especially at your gas lift control valve.
Because your temperatures would start to decrease or drop.
Yeah, they start trending toward atmospheric temperature as you're losing gas flow to the wellhead, essentially.
Oh, okay.
You'll also see too where you might have a set point for your injection rate, and the set point's no longer matching because they're usually trying to calculate with a differential pressure across your injection choke or valve. And it's saying that, wow, with this injection pressure differential that you have, you should be injecting 5 million cubic feet a day when you're really putting in a half.
Right.
So it's another way to pick up that hydrates are happening between October and March in New Mexico, it seems.
Or yeah, that's right. Pretty much anywhere in the U.S. So that data point, that temperature on your injection gas, is that something that's typically built into the meters, or is that like an auxiliary thing that you usually have to
I think that would be an additional.
Okay.
Same with wellhead temperature, it seems. Although once you have a pressure transducer, a lot of times pressure transducers, they're temperature compensated.
Right.
So they're measuring the temperature to give you a more accurate pressure. So that temperature is already being measured.
Right.
You just need to be able to grab and pull it in. And we were talking about that a little bit, but there were some experiments we had done in the past. And if you think about it, your reservoir is a certain temperature. And the faster you get that fluid from the reservoir to the surface, the hotter it's going to be at surface.
Right.
Because you have less time to lose that.
Lose that to the environmental.
And so the simplest way to tell how well you're producing is compare those two temperatures. The closer you are to your reservoir temperature, the more production that you're making at surface. It's dumb, but it's a way to do a bit of optimization. Make it as hot as you can because the well's flowing as hard.
Correct. Yeah, and the higher that temperature, the more production you're making off the well.
And even with a gas lift well, it doesn't matter because the gas can't carry as much, doesn't have as much heat capacity, so it'll turn to the temperature of the production fluid as soon as it comes into the well. There's a brief cooling over the valve, which you can see with fiber, but then it'll take off and heat back up real quick.
That makes sense. And, that's been a discussion that we have a lot of times, more from like well site style compression to where they have the compressor at or near the wellhead. And then in the winter months, bypassing the coolers. Sending hot gas right off the compressor. Now, of course, it might have some HSE concerns because you are discharging maybe 180 degrees or so. But the question always arises when an operator is new to that is how is that 150, 180 degree Fahrenheit gas leaving the compressor going to affect the gas lift system? And that's the kind of the response we tell them is the gas does not carry, it cannot carry enough temperature. So especially if your injection lines are buried, by the time it reaches your wellhead, it's already equalized with your ambient temperature. So you're not really going to have a temperature effect on your gas lift equipment when it's leaving at that higher temps from the compressor.
Also with that, for gas to go down the casing, make its way down to the valve, come back up the tubing is hours.
Mm-hmm.
And most of that transit time is in the annulus because the velocities are really low for the gas.
Because your annular space is a lot bigger than your production space.
And once it gets into the tubing, then you have all this liquid added into the gas lift gas that you're injecting, and it just zips out of the well. But about 95% of the transit time for the gas is taken in the annulus.
Oh, okay.
And so let's say that it takes, for a 10,000 foot well, million cubic feet a day, 5.5, 7 or 8 hours, just kind of guessing at that for the total time from injection to production of the gas. Well, it's going to be over 7 hours for just the gas to get to the bottom before it comes back out. So if your first valve's at 2,000 feet, it may be 2 hours before the gas gets from the top of the wellhead down to that valve. So that's plenty of time for it to cool off to the geothermal temperature around it and production temperature.
Right. Yeah, that makes sense. And I mean, not to get off topic of this, but that goes into the optimization piece too, is that if you're making adjustments at surface for your injection gas, just like you mentioned, it may be 2 to 7 hours by the time that little unit adjustment you've made at surface has made its way all the way downhole and back to actually affect the production of the well. And no, those are really good points. And back to the temperature probe, East Texas, a lot of bulk separation, two-phase production, very little oversight of individual well actual production. And that has always been my recommendation, is on the marginal wells, put temperature probes. And from there, if anything, we can tell which wells are producing and which wells are not producing.
Yeah.
Because that's a very common thing, is they might send 32 wells into a bulk separator, and 10 of those wells are making 90% of the production.
Right.
And then the rest, even if I optimize, you can't tell, 100 MCF increase on a 30 million a day bulk separator. But if I put a temperature probe in, I can at least tell, is the well producing, or has it developed a hole in the tubing or a leaking valve, and we're just circulating above the fluid level.
We would see that with our wells in Nigeria too, offshore. So you'd have a platform, you have these really high productive thousands of barrel a day wells, but there's hardly any SCADA, and you don't have much data coming back. They get tested maybe once a month. And if one of those wells is down, you may not even know it unless you had something like temperature data to tell you that.
I see.
In the meantime.
Yeah. And with that temperature probe, so I'll give you my opinion. I've never actually physically installed one. I think it's a great idea. Apparently nobody else thinks besides you and I, because I've been unsuccessful for 10 years to get one installed.
Right.
Do you typically just put that, if it is a auxiliary device, are you putting that like right above the swab valve, or are you putting it more on like your production line downstream of your wellhead? For me, I'd picture you want it as close to the wellhead as physically possible to prevent extra temperature loss as that production moves down the flow line.
So the temperature loss on the production side is not quite it doesn't happen as quick if you have a lot of liquid that you're producing there. But normally, I think I would want it on the flow line coming out of the well and before wherever the choke is at, because you will get some cooling across the choke from the gas as you take that pressure drop there. So somewhere between the wellhead and there. If you already have a pressure gauge there, then that would be a good spot where you could get it. But I mean, even just if you have, there are a number of temperature sensors you can get now that you just clamp onto the pipe and then insulate it into place.
So that'd be similar to like what I have on my pool, is I have a temperature probe just clamped onto the PVC pipe.
Yeah, and a lot of times, even now, they'll have ones that compensate for the wall thickness.
Okay.
So you can put in, set it up with a certain wall thickness, and it'll try to back calculate whatever heat loss you might have through the steel to give you a better temperature inside.
Interesting.
And then you can talk about if you want to put it, you'd probably put it on the low side so you're getting the liquid temperature versus the top.
Maybe protect it from like the sun if it's not shielded.
Right.
Yeah. Okay.
So there are ways to do it and get 80% value from the data instead of nothing.
Yeah. Well, and exactly like what you mentioned, where I see it being beneficial on infrequent well tests. In my opinion, maybe marginal wells that are having to compete with higher producers all in the same facility, to be able to understand. And a really dumb way to look at it is, if it's ambient temperature, it's not producing. If it's over ambient temperature, it's producing. But you can also, like anything else, dive into more details, and you can calculate what your flowing surface temperature should be based off of production rate, and then give it a band or a range of that. Say, hey, if this well's producing, it should be roughly 120 degrees Fahrenheit. And if it falls out of that one way or the other, then at least my production's tapering off. Or maybe I got hit by an offset frac and now my production, or I've just simply optimized and now my production is better than what it should be, right?
Right.
And so you can kind of set those ranges to understand that.
And you may even be able to correlate it back to if you have a bottom hole pressure gauge, which is really nice to have.
Yes.
Then you can look at that over time too. If I'm getting down to this flowing bottom hole pressure, I'd expect this temperature at surface with this production rate, etc.
I see. And you talk about bottom hole pressure. Let's move over to that. So I jokingly talk to operators that a downhole gauge is going to obsolete most of what I do. I hope it doesn't, because I like my job and I have bills to pay. But it has become, in my opinion, a game-changing tool from a gas lift side. Is you get, so historically, the only visibility you have on gas lift well, casing pressure, tubing pressure, and injection rates. And then you hope those three are either looked at or gauged correctly, right? And from a downhole side, from a hydraulic side, you really had to rely on models. And a lot of them are empirical models that are older than I am. And with that piece, then you had to rely on extra data to just simply build those models. And what I found with the downhole gauge is, assuming that it's working, that it's powered up and actually reading, is you get a pressure downhole and a temperature downhole, and the accuracy on either a piezo or quartz gauge at this point, I mean, it's like multiple decimal points back in terms of drift and accuracy.
There may be some reservoir engineers who could use some more, but
probably. But for us, simplistic operation guys, that I'm happy to get just 10 psi accuracy. Hell, I'd probably maybe take even more than that.
Well, and even if you're trying to model your way to that flowing bottom hole pressure, most of your nodal analysis software assume that you're injecting gas lift gas at a single point.
Yes.
And do you know what that point is?
Yes.
Are you injecting at a single point?
Very good point, because what we've found with the unconventionals, especially as the demand for higher injection rate has increased and the demand for smaller valves to fit inside the production casing that we have, that has become a big topic, is that we're learning that we're rarely lifting on one single point, that most of the time it's multiple points open. And there are design changes you can do to force a single point, but I think it's so detrimental to the actual lift depth that you're better off multi-pointing than trying to discount pressures to essentially force a single point.
Well, then when the operator might just leave their gas injection at 1 million for much longer than they need to, then you're kind of guaranteed to have some multi-pointing there as you're trying to work your way down.
Yeah, you're exactly right. And with that gauge data, it's been incredibly helpful. And, again, like the temperature, you can look at it from a very simplistic viewpoint of, if your gauge pressure is going down, you're doing good. If your gauge pressure is going up, there's something, possibly wrong. But of course, you can use it to validate your models, make sure your flow correlations are correct, identify multi-pointing, right, where you're actually lifting the system. And then for me, it seems like it gives you some really, insight as to how you optimize. And I'll give you an example of that, Michael. So this was a Permian Basin well, I think Martin County well, roughly about 10,000 feet deep. Downhole gauge, you can see early on that we had a lot of downhole pressure oscillation, slugging of the well, which of course we could also see at surface pressures as well. But one of the things that really kind of opened my eyes to it, and why I grabbed the snapshot a few years ago, was when we did make a adjustment on injection gas. This one was severely under injecting. Bottom hole pressure was way too high, and the well was just in this really erratic slug flow. So the first step was to increase our injection gas rates. But the thing that really kind of did it for me was the time that it took to really stabilize our bottom hole pressure.
Definitely.
I mean, it was days.
Right.
And this was one single adjustment in injection gas rate that it took roughly 4 or 5 days of a declining pressure before it finally stabilized out.
I've seen the same with, let's say that you lose gas lift to a well because of hydrates. Mm-hmm. So all of a sudden you have no gas supply. And so your flow and bottom hole pressure comes up, and then you've got to get it back down. So you get the hydrate cleared, you get the gas lift gas going back to it. It can be days before it gets back to the flow and bottom hole pressure it was before with these unconventional wells.
Yeah.
So you've deferred production that you could have had because a hydrate took you out.
Yeah. And it took you that many days to get it returned to that drawdown and stabilized. And, again, prior to these downhole gauges, and very similar to what you mentioned about the time it takes for that gas to travel its way down, I was always under the impression, mainly from field training, of you make an adjustment and then you make another adjustment 12 or 24 hours later, right? Well, in a case like this, if we were making adjustments during this decline, we could have completely skewed what we were trying to achieve because we weren't allowing that time to really unload and stabilize at that pressure.
And with the conventional well, you can do that, where you have a high enough productivity that the well reacts quicker to the changes that you make. But for unconventionals, not so much. But it really helps to have a gauge to see when things do stable out, which is kind of a segue to well testing, where you want to know that the well is stable. If you made a change, your bottom hole pressure has stabilized, and then you can hold in test long enough to get an accurate enough test for that. There was the case that we saw where this was in Australia, and the regulator there would allow 1 hour well tests.
Oh, really?
Now, these were conventional wells, but 1 hour is not enough for any well, for a well test.
Right.
And we saw it where a change was made to gas lift rate, and they didn't have a bottom hole pressure gauge, but we were looking at it with temperature. And even from temperature, you could see that it took maybe 30 minutes before the well stabilized after this gas lift rate change. So the 1 hour well test was really more like a 30-minute well test, because the data in the first half of it was all dynamic. There's nothing useful you could get out of that. Yeah,
you're waiting for that stabilization period. And you bring up a point with that, is that maybe on the onshore we have more than an hour. But in a case like this well, if we try to well test anytime during this decline, our production would have been skewed before our next well test. And then that could have reverted back to a decrease in injection gas rate, something that could have further affected production down the road to the next well test.
Yeah, it makes it quite challenging for how you would stagger your well tests and your changes to injection rates to try to get the best numbers there.
Right. Well, and when I look at that from a downhole gauge standpoint, I understand that a lot of this stuff can begin to be automated at this point. But I still like to discuss it and view it as like a very manual process. But for me, I look for that flat line, that stabilization, to be my next indicator to make another change, or to drive another change. And this one, had two kind of step change rates, right? But that secondary one was made only after we, targeted that first stabilization.
Then too, you'll have your well decline that you're looking at, and you're trying to see if the changes you're making are getting you below that, especially when they take a while to start working, like you see there. But when you have that kind of data coming back, well, if you're not able to test it when you want to, just go off the flow and bottom hole pressure data, because that's your direct indicator of how hard you're pulling on the well and how much production that you're making out of it.
Yeah. And that's a good point, is that, you almost, in my mind, if you have that downhole gauge data, you could almost optimize or prefer to optimize off of that data versus well tests.
Mm-hmm.
Now, you could maybe use well tests to just kind of confirm everything, but in my head, you would almost like neglect the well test and focus on that.
Right.
That downhole
Because you have
pressure.
one direct data point that I believe more than I do well tests.
Mhm.
So with well tests, there can be quite a bit of variability there. You mentioned the bulk testing or where you're trying to allocate back to wells. Also, if you go with three-phase separation, three-phase tester, you can have issues with how much water versus oil is it making. Maybe not as much with lighter oils, but when you get to heavier oils, well, the heavier oil and water look about the same to the separator at a certain point. At API 10, the density is the same for water and oil.
Oh, okay.
And if you're trying to use gravity to separate the two, then they don't really want to separate.
Right.
So you can get, when you're getting into that, you can get some really varied measurements of what your water cut is, where you might just have to take a shake out of it. Just pull some and sort it. We had a field offshore California like that where the oil was super heavy, and that was really the only way that you could trust whether you were getting a good water cut measurement out of it.
Oh, no kidding.
To get a hard shakeout.
Shakeout to see. Yeah, and that's a good point, and that's why I wanted to bring up this presentation here, talking about that testing, right? Is that outside of those well tests, what are the things that, like you mentioned with the shake test, like what other things can operators look at possibly implementing, again, putting it in that troubleshooting toolbox to where if they're getting well tests and like, this doesn't make sense.
Right.
Like, what can they do besides just sending the lease off to go do another well test?
Mm-hmm.
Because usually by that point, they're going, I got so much other stuff to do. I don't
Yeah.
want to have to bring this well back into test that I just tested last week.
Yep. And
so I wanted to share some of this. We don't have to go through the whole thing, but if there was any specific points to kind of touch on that.
So go a little further. There should be one that shows transducers on pipe.
All right. Bear with us, guys. We're going to jump
a little further.
Jump across through a couple slides to reference a few things.
Yeah, I think I have one with a picture of us doing the testing.
All right.
Eventually.
And these are just additional ways to additional ways to confirm some of those well tests or help validate that information.
Right. So one of the things that's key for gas lift diagnosis is, well, how much gas lift gas am I injecting?
Mm-hmm.
And you'd think, well, that's easy. I know that. I have a meter. Well, do you have a meter? There are a lot of places where you don't have meters for individual wells. Fortunately, in unconventionals, we've gotten a lot better about putting a injection meter on every well.
Right.
But there have been plenty of fields out there where the only meter that you have is the test meter.
Mm-hmm.
So you're really only getting your gas lift injection rate when you put it through test.
Because that test meter is going to be your formation gas plus your injection gas coming back to it, right?
Right. They might have a way to route your injection gas through your test meter or your test separator setup to get that rate.
Oh, I see.
We would have that to where then you can separate out the total to see how much is formation versus the injection gas. But one of the issues with that is that, let's say you only have one place where you can test your gas lift injection rate. Well, does every one of your wells have the same injection rate? No. Is the meter the same for every test? Yes. And so it's not going to be in range for every test. It's not going to be accurate for everyone, especially if you're using an orifice plate type meter for your gas injection rate. Also, if you only have one point that you're testing at there and every single well has to go through it all the time, eventually that nice square-edged orifice that you have is going to turn into a cone. And it's really not going to be accurate then.
Right.
So sometimes it helps to have, like we were saying with pressure before, a secondary device that you can bring out to verify what that value is. And so we'd had enough challenges with that we did a bunch of testing, which you see on the slides there, which was for a few different portable ultrasonic gas flow meters. So these are meters that you can take around. They're for single phase flow only, and they have different transducers depending if you're doing liquids or gas. And we wanted to make sure that we can measure what a gas flow rate was through the flow line without having to break it or anything.
Mhm.
Just set transducers on the outside of the pipe and measure that rate. And the way it works is you have these two transducers that you would set on the pipe, and acoustically you're sending a signal through that bounces to the other one.
I see.
And that transit
Yeah,
time.
I think you had a slide of
Yes,
that.
that's
Let's
right.
go back
Just
a
wanna
few. I saw it.
Probably one more.
Maybe
two
one more. This one?
Yeah, that one's
Yeah.
good.
Okay,
So-
so you're talking about a transducer on top,
Right.
and on bottom, in the white and yellow of
That's
the flow
right.
pipe.
And then you send a signal through, and it goes from one to the other.
Mhm.
And sometimes you'll bounce it down and back up like a triangle where they're on the same side. It just
Mm-hmm.
depends on the geometry of the pipe, and there are guides for how to do that. But that transit time of the sonic signal from one to the other will be affected by a small amount by whatever's flowing through the pipe, because there's a speed of sound through whatever media is going through the pipe.
Mhm.
And so that's what the device is using to tell you what the flow rate is going through the pipe. And it helps if you have higher pressure that you're using. So gas lift gas is one of those. Helps if the gas is dry. It isn't always. It helps if the pipe is bigger, because if you have a smaller pipe, then that sonic signal is just going to want to ring around the
Oh, I
outside
see.
and take a shortcut.
Mhm.
But if you're looking at you can get it done with 1-inch pipe and up. Smaller than that's kind of tough. 2-inch is great. 2-inch and
I was
bigger.
about to say, hopefully they're not injecting gas in anything smaller than 1 inch.
Yes,
Yeah.
I've seen.
I
places that-
bet you have. Yeah.
But this works pretty well. There's we were using a flexometer. That was one of the ones in this test. So our gas lift experts who go out to do surveillance and optimization have one of those in their toolkit.
Oh,
So
I
they'll
see.
bring out the transducers, go put them on the pipe, and they put them down. And on the portable meter, you put in a few things like the pipe wall thickness, speed of sound through the gas,
Mhm.
which you get from an echometer also, and then you can measure that flow rate going through. So it's a good secondary confirmation of what your test meter or other meter is giving you for it. Or if you don't have a meter, then you can get your gas rate without having to send the well to test.
Ah, that's fantastic. And that right there, and especially how you mentioned that is something that is portable, that an AL tech or
That's
lease operator, somebody can carry with them, because we run into this quite frequent, is production tails off. Injection gas rates stay nice and flat. Wellhead pressure stabilizes with flow line, and operators trying to figure out why are we sending gas to the well, or supposedly sending gas to the well, but production's dropped off and tube pressure is equalized with line. Well, we go out there and the meter is reading a injection gas rate. You know, we have that benefit most of the time, like you mentioned, that most onshore gas lift wells at this point have a injection meter. But then just downstream of the injection meter, the control valve is just this giant white icicle. And you're like, this thing's frozen, yet we're still showing gas through the orifice plate. Like,
Right.
1 + 1 doesn't equal 2 here. And something like that would be a very useful way to show that, hey, we've plugged up here, meter's incorrect, and either we're just simply not injecting any gas, or the value that it's telling us is significantly off what we're actually breaking through into that well.
So picking on Australia again, but there was another well. that
Hopefully
we
there's
saw.
no way
Yeah,
from
hopefully
Australia on
not.
this.
We might be
Well, they'd be sitting
Yeah.
at close to midnight
Right.
at this point.
So we were
I
out
think we're
there.
safe.
They had a well that they said they were injecting, let's say, 1 million cubic feet a day gas to. Okay, no worries. So we figured we were going to do some testing on that well, and we wanted to verify what they said they were injecting.
Mhm.
So we took our portable ultrasonic meter, put the transducers on the pipe. It was running up above in the well bay, and get it all dialed in, turned it on, and it's overranging the device. It's like the velocity through the pipe is so high.
Overranging
Yes.
the ultrasonic meter.
Yeah, it was
Okay.
saying the velocity going through is so high, we can't even calculate the gas flow rate that you're injecting. Well, that's weird. They're only doing 1 million. This is a 2-inch pipe, but we're getting a green light that everything's set up right and it has a solid signal. So the guys look at the transducers, they change the placement of them, move them somewhere else on the pipe, try it again, same thing. So then somebody goes to look at the well where the control valve is, and it was the opposite case Well, the indicator for the position for how much gas is being injected was knocked off. It wasn't even there. It was reading what it had been sometime in the past.
Oh,
and meanwhile, the control valve was wide open. That well was getting all the gas gas that the compressor could give it. It was taking like 6 million cubic feet a day.
Just taking the
just
whole
blowing gas. It was just sucking it all down.
Wow.
So you never know. You might run into stuff like that.
Yeah, and that's a good point. And like, you know, when you look at this, so during like my training, very similar to what you've discussed, I like to break up surface and subsurface when we go into troubleshooting,
yes.
right? And really, troubleshooting is kind of a broad overview term, but troubleshooting optimization, monitoring the well. But a lot of the things we talked about, data logger, temperature probe, ultrasonic meter, a lot of those things, again, are driven to that surface piece of the gas lift system. And one of the reasons I like to do that is, one, most of that's visible and accessible by almost everybody, right? And two, comically, 90% of the time when we get a call about production being off, the first thing that they say is, got a bad gas lift valve.
Right.
Well, maybe we do.
Maybe.
Don't get me wrong, that's possible. But let's make sure we're actually getting gas to the well, and wellhead pressure is not 800 pounds when it should be 100 psi. And, you know, our temperature probe shows that we're producing and going through all that. And so I like these, you know, tools and things that you can do, because really with some, in my mind, some simple training and the availability or access to some of these tools, people can go out and, you know, validate and check that information, and possibly defer a workover or defer having to pay a third-party service technician to come out to work on the well, you know, or like you mentioned too, maybe get the well on production longer or quicker, excuse me, so you don't have that deferred time where it takes to just simply unload and return the well back to
get
production.
Back where it was.
Yeah,
I do the same in mine when I teach about exhaust every possibility on the surface first before you start messing with things downhole.
Yes, sir.
Although there are a few things in between which you can do from surface to learn more about downhole.
Okay.
One would be acoustic fluid level shots.
Yes, I've always enjoyed fluid level shots, but and you know, there's other people besides Echometer, but Echometer is
it's like the folks, Kleenex right? Of fluid level
right,
shots.
Yeah. So I do try to be cognizant of calling it a fluid level shot. Try to call it a fluid level shot rather than just Echometer.
Yeah.
Kind of like Xerox.
I fail most of the time.
I do too. I kind of go back and forth. But you know what you're looking at with a fluid level shot, and now with kind of that dual reading fluid level shot, that has become incredibly helpful for finding things like multi-pointing holes in the tubing, things like that. Yeah. And, you know, when you look at a fluid level shot, again, these, you know, Echometer, because they're the most accessible where we operate, is you can get some really good markers downhole. And with the newer, I guess it's not very new at this point, but the TAM software, so everything's kind of computer driven. You can adjust PVT properties, velocities, and you're not having that 50 foot of white tape blowing in the wind and having to count it. Is very helpful.
One thing that excites me about it too is if you're unloading, say a conventional well, then you can just take multiple shots over time and watch how your fluid level in the backside is dropping and you're unloading like you plan to.
Yep, from gas lift valve to gas lift valve as you work down.
But even for an unconventional well, Echometer and others now are working on systems where you can have automated fluid level shots. So maybe once an hour or a few times a day, you can get a shot, have it analyzed, and give you a number. So then you could track over the time as your reservoir pressure is dropping and you're transferring from valve to valve down. Now you'd have to leave it on the site for that for months probably, but it's useful information where otherwise you're having to back calculate into it from your bottom hole pressure gauge and modeling. But otherwise, you could do it that way.
Wow, that'd be really helpful. So for a case like that, would that be in addition to something like a downhole gauge, or could you almost use that in replacement of a downhole gauge kind of.
I think this might be addition to it there.
Okay.
I guess it depends how the gauge is ported to. If you do have an annular pressure on your gauge above the packer, then you could look at that for what you have on the backside to try to figure out where that liquid level is there.
I see. Yeah.
But
And that brings up another good point too. Back to the gauge side, is most gauges run, at least US, are single sensing gauges. So either sensing casing pressure for annular flow well or tubing pressure for a conventional or tubing flow system. There are gauges and they're readily available. And I don't think there's much of a price difference. There might not be a price difference at all. Cost difference between the two that have dual transducers. So one measuring tubing pressure and one measuring annular pressure. And for when I look at, the application for gas lift wells, that's fantastic.
yes,
Because you can, check those PVT properties, especially your gas specific gravity,
right.
or more so how your density changes as your surface injection pressure change. And to be able to register both your injection pressure at the bottom of your tubing and your production pressure at the bottom of your tubing.
And it makes a big difference when it comes to designs and operation of your gas lift system, because you might say, oh, okay, yeah, sure, my gas gradient is 0.8, and I will use this for the life of the well for this design.
And just one linear line.
That's it, all you got. But
Yeah.
that's not true. It will change. It depends if you're not dehydrating your gas. The conditions of the gas coming in are going to change over time too. So it's just another great thing to have for troubleshooting. Say, oh, wait, my gas is heavier than I designed for. So how will this affect the operation of my valves if they are all operating properly? It could be something else that's the issue.
Yes, that's a good point. And that goes back to we've talked for the last 52 minutes about, post installation, right? But that data there can be helpful on the design side too, making sure like your delta P's between operating valves are maybe not too close together, right, or too wide apart, especially if you have of course you need historical data to kind of improve those designs, but help you kind of optimize and do that continuous improvement on the design side if you are seeing specific gravity changes, gradient changes from that downhole pressure information on the injection side. So yeah, that's really good. And Michael, we're running up close to time. I like to save the last few minutes for kind of Q&A and what you're looking forward to. And unfortunately, we could probably sit here for the next 6 hours.
I'm sure
and talked about this, but we don't want to make the audience suffer through that. So I have a couple questions for you. One of the big ones is, since you're directly related to a very large oil and gas operator that seems to be getting larger and larger on an onshore basis, you guys have some fantastic technology, access to a lot of different service companies, a lot of different basins, a lot of just different production, specific to gas lift. What are you looking forward to, without giving away any trade secrets? Like, what are you looking forward to in the, say, unconventional gas lift world, especially from an operator that you work for?
Well, one of them that makes me excited, we'll see how it goes. And more service companies, vendors are getting into this, is surface control gas lift.
Okay.
We've been talking about data quite a bit. So if you're looking at a system with electric gas lift valves, for instance, that has pressure and temperature measurements either along with or near the valves, then now you can get a live flowing pressure traverse through the well. We didn't even get to talk about those.
Yeah, no kidding.
But then you can get that profile of your gas gradient on the backside. You can see exactly where you're lifting at in the well.
Because you have multiple data points throughout the
tubing string. You can look at the differential pressure across each valve. You can calculate the flow through each one. It's all these things that we've historically had to try to model into with, as we've said, incomplete or incorrect data at times. And then you can get, just like with the bottom hole pressure gauge, you have a direct point from the well, and now you have these spread out through the well with multiple of those. And then you can also tell the valves to open or close
And
So-
you're not having to rely on that pneumatic
That's
pressure to force those closures as you get deeper into the well.
And even better, you can use your entire compressor discharge pressure at surface to lift from the bottom. You don't have to take the pressure drop
To
from valve
ensure
to
that
valve
those
to valve
valves
to ensure
close.
that they close.
Yeah.
So you can just digitally make it happen.
I see.
Now,
Wow,
of course,
that's pretty neat.
there's the reliability aspect of it.
Yep,
But
I
the
can see
good
that.
thing is that usually our tubing goes pretty quick with these wells. So there are a lot of workovers that will be planned anyway.
I see. That's pretty neat. Now, when you get into that type of system, is there a lot of like development or technology following behind that to help automate, a lot of those adjustments, or is it still relying on somebody to go out there and press a button at the well side or sitting on their computer doing it remotely?
I think that is right in line and parallel with the development of the valves themselves and the control systems. Is how do you just have automatic optimization of your wells, so you can work down as the reservoir pressure drops, change your port sizes as you go, and just let it run on its own, which is important because, well, we have more wells and fewer people. Everybody does.
Yes.
It seems like. And
Yeah.
so the less time and effort you have to spend on perfecting your gas lift performance, that's more time people can do with other things.
Yeah, that's a good point, is that, when you're looking at any type of production, especially when you start doing these optimization things, what you're ultimately saying is more time. More time. And maybe for a very employee heavy company that helps, or an operator that has a very small field. But like you mentioned, the fields or the number of wells are growing and the personnel are either staying the same or possibly shrinking, and then trying to put those things in place just to help everybody a little more. I was having kind of an offshoot conversation with oil and gas operator that each engineer has like 600 to 800 wells. And I asked him, I was like, how do you manage that? Like, we don't. We have, like basically the top 20, percent that produces the bulk of the production. We focus on those, and then everything else is just simply make sure it's on when land says, hey, we're about to lose the lease because this thing's been off production for so long. And so, you talk about some of that technology to maybe help with that, to make it less cumbersome.
Think about what you might be missing with those.
Oh, I know. Yeah, it's there, potentially huge. I mean, you get a barrel a day extra out of one of those. That's a lot of, production.
That's right.
Yeah. So that's really neat. So last kind of thing before we wrap up, we're getting pretty close to time. You mentioned like what you're excited for. That's pretty neat. What do you see, that's being outside of this new technology? What is being done correctly in the gas lift world? Just from optimization, troubleshooting, things like that. Are you seeing like designs kind of catching up with unconventional concept and operators learning about how to deal with them on a day-to-day basis?
Well, I find it's been really interesting in the last 10 years, let's say, because when people were first getting into unconventional, it's like, all right, put rod pumps out there and ESPs, and pretty quickly found out that, yes, the ESPs have their place, but a lot of these wells are just born for gas lift. Right?
I see.
And just the whole renaissance of conventional gas lift equipment, because we've been in the mode of side pocket mandrels offshore for years and years. And so just coming back into almost relearning as an industry how to deal with conventional equipment.
Oh, that's a good point. And like you can look at like what API is doing with 19G2 absorbing what is 19G15. Yeah. That's a good, interesting point. Okay.
So that, and then all the things that weren't there before. We'll say back when conventional mandrels and valves were onshore, it was conventional fields, right? Well, now we're running them in unconventional fields after we've hydraulically fractured these wells. And the wells have a much different production profile too. And so it's just a whole different mindset that I find fascinating for how gas lift is, stepping up to this challenge to deal with these wells.
Yeah, I can see that. And you're right, is that it's been a very steep learning curve. But I see the industry really stepping in to do that. And, some of these tools that you mentioned today have really helped operators operate their existing gas lift wells, but then historically you can grab those data points and continuously improve in the future. So, well, Michael, we are on time. We want to let everybody get back to their day. I do appreciate you taking the time to come out here and share a little bit of your expertise. And I know we could probably sit here all day talking about that.
We probably will.
Yeah, we probably will. Maybe over lunch. Well, Michael, thank you. Guys, thank you for everything. We appreciate it. Hopefully this new platform worked out and everybody was able to get on, and we'll see you guys next month. Bye.